Now we've got an example where we need to reverse the chain rule. And this is a tricky example, but it's maybe not for the reason you might think. We've already looked at how we can reverse the chain rule where we have an exponential function like this. We've got e raised to some function, and a perfect question would have f dash x out the front, so the differentiation of whatever's up here in the power. But if we don't have that, but we have something that's close, we've seen how we can adjust for it, and we can use this rule to go backwards and integrate. Now, the reason this example is so tricky, actually that should have a dx on it, sorry about that. The reason this example is so tricky is because it takes us a minute to work out what sort of question we've got. It's looking a little bit like one of these because we've got e to the power of something, and yet what's down here is definitely not the differentiation of 2x. It's not 2, it's not even close, and in fact it's got x's in it. So it's tempting to think if we're looking for this that it's just not there, and the truth is it's not. It's one of these other sort. Now, here what we've got is, and this is something we've learnt already, but we just haven't applied it to exponentials. We're integrating something where we've got some function raised to a power, and we know that the perfect question will have f dash x out the front. The reason we want that there is because if it is, we can go straight to saying we've got that same function raised to a slightly bigger power. We change n to n plus 1. We divide by the new power, and we add c. And we can verify that this works because differentiating this one, the n plus 1 would come down the front and cancel with the n plus 1 that's down below. But we'd also have to change the n plus 1 to n, perfect, and we'd have to differentiate what's in the brackets and bring that out the front, which is why we'd need this. So this is the situation that we've actually got here. And we want to get it in the form where we've got some function raised to a power, and out the front we've got something that's pretty close to the differentiation of what's in the brackets. So to generate that sort of question, we need to change the look of this. And the first thing I want to do is rewrite it so that this part here is raised to a negative power. Because straight away now it looks more like this kind of question. We've got some nasty function in here that's raised to a power, and we need to check whether the thing out the front is the differentiation of what's in the brackets, or hopefully it will be close. If it's not, we can't do anything with it. So what we need to do here is think, well, what is the differentiation of what's in the brackets here? Well, if I'm differentiating this part, I'm going to need to bring the 2 down, so I'll have minus 2 e to the 2x. That's what I want to differentiate, and so my next step is to write the ideal question that I wish I had. I wish I had minus 2 e to the 2x out front, and then all of this part in brackets would be fine. Raised to a power, I can deal with the minus 3. This is the question I want, because it now looks like this. All right, now I need to adjust for it, because this is not the question I was given. I was given this one. I've changed it. I've multiplied by minus 2. How do I account for that? I need to, at the front, put 1 over minus 2, or really just call it minus a half, because minus a half times minus 2 is 1. So that'll get me out of trouble. So now this minus a half needs to stay out the front, as I now go ahead and follow this rule to find my integral. All I need to do is write down the function, raise it not to minus 3, but a number that's 1 bigger than that, minus 2. So I've got 1 minus e to the 2x, all raised to minus 2. And then I need to divide by the new power, minus 2. And then, of course, I need to add my constant. Now I need to look at it and just see if I can tidy it up a little bit. I've got minus a half times by another fraction here. I can put my 2 and my minus 2 on the bottom together to make minus 4. But if I've got minus 1 over minus 4, that's just a quarter, isn't it? So to tidy it up, I'm going to do 1 minus e to the 2x, all raised to the minus 2, over 4 plus c. And that would be fine like that. If you'd rather write it so that you don't have negative indices, of course I could take this whole expression and move it down to the denominator and just raise to the power of 2. So that would look like, I have my 4 out the front, and then 1 minus e to the 2x squared plus c. That would be equally good. So whichever one you come up with is fine there. So quite a tricky question. The thing that made it tricky was working out what sort of form we wanted it in. Once we had that, reasonably straightforward.